Hi guys, so very excited that we're going to be doing reciprocal trig ratios today. Sorry that I couldn't be there, but I'm sure you'll survive without me. So what I would like to do, and what you should have done already for your warm-up, was to complete your unit circle. Hopefully you got this sheet at the front of the classroom. If not, go grab one now, pause the video, and complete it as much as you can by memory, and then go back and look to fill that in with any missing details and just check to make sure everything's right. So what I've done here is I'm just going to click this. I think I used my paste button. Whew, much too big. But remember, this is our kind of unit circle from last time. It's hard to see, but you can see if I kind of fill in the blanks here around that would be my 45, 60, and 30 all the way around. So you can kind of see that visual. Semicircular, not bad. These are all the trig ratios that we're going to be looking at. So today, please make sure you have your unit circle beside you because we're going to be using the idea of reciprocal ratios from exact measurements. So we need to determine those exact measurements first. Big thing, just review your CAST rule. Cosine is positive in the right or in the fourth quadrant. Everything is positive in the first, sine in the second, and tangent in the third. So with that in mind, I'll just take this and we'll just delete it and we'll do our first question. So the question says determine the exact trig ratios for the angle 300. So first thing we want to do, oh sorry for that flip, I will try not to do it again, but you know me, no guarantees. First thing I want to do is I want to make a grid. If I'm looking for something with the 300-degree angle, remember that's relative to the reference angle. So 300 will be all the way over here, which makes my interior angle 60 degrees. Okay, so I have my reference angle. What I want to think of now, okay, what is the sine of 60 degrees? And I wrote theta instead of 60. Negative root 3 over 2. Remember, that's the same as the sine of 300, which is negative root 3 over 2. From this point, I want my other two trig ratios. Cosine of 300 is 1/2. And again, I'm looking at this point in my unit circle. This point here at 60 degrees is 1/2 comma negative root 3 over 2. Okay, so that's my cosine is 1 over 2 at 300 degrees. And the very last thing it's asking me for is the tangent of 300, which remember is going to be the sine of 300 divided by the cos of 300 root 3 over 2 divided by 1/2. Nice, cancels out, and I get, oh, don't forget that negative sign, negative root 3. So those are my tangent ratios. Remember, that's my first special triangle that we talked about with that 60-degree reference angle. In terms of a reciprocal trig ratio, every trig function we've talked about so far, sine of theta, cosine of theta, and tangent of theta all have reciprocals. If I were to ask you, let's say, what is the reciprocal of 2 over 3, your response would more than likely be 3/2. The same thing applies here. When I'm looking at my sine, cosine, and tangent ratio, first I want to define the ratio to be 1 over the sine of theta. So that's that reciprocal ratio, which we call cosecant of theta. Okay, now I'm going to leave a little bit of room and just go to define my other terms here. The reciprocal 1 over cos of theta is called the secant of theta. The reciprocal of tangent, 1 over tan theta, is the cotangent of that same angle theta. Now instead of writing cotangent and secant and cosecant down all the time, we take this and we abbreviate it. cosecant, CSC of theta, secant, SEC of theta, and cotangent, COT of theta. Now, one thing I'd like to note, just because I find students can sometimes get this confused, cosecant goes with sine, not with cosine. So that's one thing I find students often associate. So we just try to get away from that barrier. Okay, so if I have a sine ratio, I automatically have a cosecant ratio. If I have a tangent ratio, I automatically have a cotangent ratio, and vice versa. So with that in mind, and you can pause that and rewind if you'd like to go back over anything, but we're going to consider a right triangle here. So we're going to draw one out. We'll say this is A, B, C. A is 12 units, so I'll just leave it. I was going to make it meters, but I'll leave it. B is 5 units, and C is 13. What is important here is because C is 13, and I'm dealing with a right triangle, my largest length must be my hypotenuse. Okay, so that means that my C is a right angle. This is important because if you don't deduce that from the question, you won't be able to solve. The overall problem is asking us to determine the 6 trig ratios for the angle. Well, the first 3 are going to be my general sine, cosine, and tangent ratios, and it wants of angle A, so that's my reference angle. Sine of A, cos of A, tangent of A. Sine of A, opposite over hypotenuse, 12 over 13. Cosine, adjacent hypotenuse. And tangent, opposite over adjacent, 12 over 5. Which makes the reciprocal functions, remember cosecant of A, secant of A, and cotangent of A, the reciprocal, 13 over 12, 13 over 5, and 5 over 12. Okay, so this would be a really nice question to see on an assessment. More than likely you wouldn't see it this straightforward, but this method for sure. All right. With that in mind, we're going to go on to do 2 more problems. The first one, it's okay, but the second one's my favorite, but we'll get there in a second. Determine the angle measurement of A given the cosecant ratio. So I can look at this. So cosecant of A, remember, is 5 over 2. There are 2 ways to look at this. I can either remember right away that the sine of A will always be the reciprocal, and as I write it the same, 2 over 5, the reciprocal of cosecant. Okay. Or I can write it like this. Cosecant of A is the same as 1 over sine of A, which is 5/2. And I'm looking to cross multiply. In the end, you're going to see I'm going to have the same result. 5 sine A equals 2. So the sine of A equals 5/2. Again, it's just up to you which kind of way makes more sense to you. Once you get to this point, either way, it doesn't matter. We get A to be the inverse sine of 2 over 5, which is 24 degrees. So either way, that last step is the same on both sides. So just right here, either or. So if I'm giving you a sine ratio, I expect you to be able to solve for that angle as well as any coterminal angles, etc. we talked about last class. If I'm giving you a cosecant ratio, again, still asking you to be able to solve for the value of A. Now the very last part I said is my favorite, and it's true. I really like these equations because it involves a little bit of unit circle work and a little bit of conversion. So we're going to go through and we're going to evaluate each on the side, and if I do any side work, I'll write it there. First term that I see is the sine of 30. Remember, that's one of my perfect triangles, which is a half. And then I'm going to look at the cosecant of 150. That's where I'm going to do a little bit of side work. So I'm going to think cosecant, remember I'm dealing with the sine of 150. So that's that base. This has the same base ratio of 30 degrees, right? It's a multiple of my 30-degree triangle, which is a half. So if the sine of 30, which remember is my first quadrant version of sine 150, is a half, that makes my cosecant of 150 2 over 1. So we'll just write that in here. Plus the cosine of negative 30. Remember, cosine of 30 will be root 3 over 2 times the secant of 300. Again, I'll do that side work over here. Secant comes from cosecant of 300, bringing it back down to its lowest degree. 300 will go down to 60, right, for multiples. And the cos of 60 is a half, which makes the secant of 300 2 over 1. Don't know why the bracket is so big. We'll make it smaller. And then the very last step, plus the cotangent of 45. I know the tangent of 45 is 1, so the cotangent of 45 degrees is just 1 over 1. And I'll write it just so you see it, but obviously that's not needed, which simplifies to 1, remember cancel, cancel, plus root 3, cancel, cancel, plus 1, 2, plus root 3 as the final answer. All right, fabulous. So you have the rest of class now to move on to your homework. There are kind of two options. There are some IXL problems online. IXL. If you want to give those a try, go for it. They're fun, and I think they're a good way to kind of intro into the homework, especially if you're feeling unsure. If you want to go right to the homework, though, and maybe come back to those if or when you have time, feel free. All right? Okay, guys, thanks. Have a great class. Bye.